Hello. So I had left you here. I asked you that you guys try to draw the graphs of these two functions. So one was number 4 here, -5 sine of pi x, and the other is the function given below. Now note here, this is a negative sign in front of the whole function here. That means flip over the x-axis. If the negative sign is inside multiplied with x, that would mean flip over the y-axis. Now we notice that in this case the amplitude is 5, the period will be 2 pi over pi because the pi is being multiplied with x here inside, so the period becomes 2. So maximum point in this case will be just the 5, and the minimum point will be -5, and we have a flip over the x-axis the transformation. So the graph will look like, of course it is going on and on, but we are only graphing it in one period. Now if the question says graph it in 2 periods, what you can do is graph on the right side of the x-axis 1 period and graph one on the left side. Leave it so enough space so that you can draw the 2 periods easily. Okay. The last one among the cosines was 2 minus 1/2 cosine of pi over 3x. So in this one there are a lot of things happening. One thing is amplitude. The amplitude is given by the quantity, which a number or a quantity which is being multiplied with the sine function or the cosine function, in which in this case is 1/2, -1/2. The amplitude will be the absolute value of 1/2. Period will be 2 pi divided by the quantity here, which is multiplied by x. So 2 pi divided by pi over 3, simplify, you get 6. So the period is 6. So what do this do, this number? Because this is going to shift everything 2 units up. So the axis, so this axis of the function moves up. Remember, both sine and cosine we draw with like kind of x-axis, above x-axis and below x-axis. So x-axis is kind of in the center. So we can call it the axis of the function. So this axis is going to move up 2 units. So that is where I have it drawn, the dashed line. Okay, and you can go in this side as well as keep going this way. Okay, and notice here the amplitude is 1/2, so it will be half above this axis and then half below this axis. The highest point can be obtained by 2 plus the amplitude, and lowest point will be 2 minus the amplitude. Okay. So I wrote the max point 2 plus 1/2, which means 5 over 2, which means 2.5, and min point is 2 minus 1/2, which is 3.5. So we can plot the graph like this. Okay, now I have it here kind of written a summary of the graphing sine and cosine function. So if you have simple basic y is equal to sine x and y is equal to cosine x, very important thing is that we want to know what are the zeros. So this is important. Zeros of the sine x. So sine of x will be equal to 0 when will it be 0? When x is 0 or pi or 2 pi or 3 pi or 4 pi and so on. Can you see what will be the numbers? So, or now we can also have negative. So you can have a negative pi or pi. So I am going to write here plus minus. And similarly negative 2 pi or plus 2 pi, both. So negative, positive, negative, positive, negative with every, and then plus minus 4 pi, plus minus 5 pi, and so on. So if you notice, this can actually be written as is equal to, we often call it that x is equal, sine of x is equal to 0 means x is equal to n pi, where n is equal to 0, plus minus 1, plus minus 2, plus minus 3, and dot dot dot. So this is kind of a formal way of writing the zeros of sine of x. In the same way, when will the cosine be 0? So when x is, if you recall, so x is pi over 2 or 3 pi over 2 or 5 pi over 2. Okay, 7 pi over 2 and so on. Okay, so I again plus minus, plus minus, plus minus, so on. So how will we write that now? So notice here what is happening, what are we getting? So the first one I can think of it as 1 times plus minus pi over 2. Second one I can think of 3 times plus minus pi over 2. Then 5 times plus minus. So we can say these are the odd multiples of pi over 2. So the cosine of x will be 0 at odd multiples of pi over 2. That is what you have to remember. So we can write it like this. Now if you know already, good. If not, then this is something to keep keep track of, remember. And even numbers can be, if you have a list of even numbers, so you can denote it by, even numbers can be given by 2n. Okay, where n goes from, n is an integer. Okay, n can be 0, plus minus 1, plus minus 2, plus minus 3, and so you get all the even integers. Now if you have odd integers, okay, so odd numbers can be given by, so we now say 2n plus 1, where again n is 0, plus minus 1, plus minus 2, and dot dot dot. So here we can write x is equal to 2n plus 1 pi over 2. So n is, so notice here I am not putting a plus minus here, because when I am giving the n, the values n is equal to 0, plus minus 1, plus minus 2, and so on. So again, this is something that you should know. Okay, now general sine function, and similarly general cosine function. So this is the most general form of the sine function. You will see a times sine of kx plus c and plus t. So this includes the shifts, horizontal shift as well. So what will be the horizontal shift? Remember, when we add a number or subtract a number into x, then that is where the horizontal shift happens. Okay, so the horizontal shift, how will you find it or how will you calculate it? Well, you have to take the k common, and then inside you are getting x plus c over k. So c over k is going to be the shift, horizontal shift. So if c over k, well, k is positive, that is for sure. We have taken k positive, k has to be greater than 0. Then c, if c is positive, then it means it will be c over k units left shift, and if c is negative, then we will have a c over k units to the right. So amplitude will be a, period will be 2k pi over k in both cases. Here I have written them side by side, all the properties, and this is what we got. Vertical shift d units, this d plus d, right? So this is the vertical shift, up if d is positive, down if d is negative. Then we have a vertical shrink or stretch of magnitude units. So if the number here is the a is between 0 and 1, actually -1 and 1, then it will be horizontal stretch. And then if you have vertical shrink, and then if a is greater than 0, then it will be a vertical stretch. So horizontal stretch or shrink is k units. So if k is always positive, remember. So if k is between 0 and 1, it will be a stretch, horizontal stretch, and when k is greater than 1, it will be a horizontal shrink. Okay, so then so once we have now the understanding of the sine and cosine, now let's move on to the tangent function. So now we'll look at the graph of the tangent function. Now in order to graph the tangent function, we have to look at because tangent x can be written as sine x over cosine x, so we have to look at the properties of sine and cosine. So we know that tangent of x is equal to 0 when sine of x is equal to 0, because I have told you that whenever a fraction is 0, this means the numerator is 0. So that's what we are doing here. So when is sine x 0? Well, we have just learned that sine of x will be equal to 0 when x is equal to n pi. Okay, all multiples of pi. And cosine of x will be 0 at all odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, and so on, and with the negative as well. So what will happen at these ones? Well, this is in the denominator, the cosine x is in the denominator, so if it is 0 means there are asymptotes. So at all these numbers, all these values, we will have asymptotes. So I have drawn those asymptotes here, and so you have to remember that. How will the graph go? The graph looks like something like the cubic, kind of a little bit like this. Okay, so in each piece, because it's repeating, so now note here, this distance pi. Similarly, this distance is pi. Similarly, this distance is pi. So what does that mean? The tangent repeats itself after pi units. So which means the period is pi. Period of tangent is pi. So period of sine and cosine was 2 pi, but here the period is pi. Period of tangent axis pi. Now if we have function tangent of kx, then like previous case, previously it used to be 2 pi over k, but now it will be pi over k. Why? Because the period is pi. So now we have to sketch the graph of tangent 6x, and then we have tangent of pi over 3x or pi x over 3. So how will you do that? Well, you will say period here will be equal to pi over 6. So which means okay, so at 0 we will have tangent of 0, and tangent of 0 is 0. When we have pi over 6, so if I plug in pi over 6 here, what will happen? I will get tangent of pi. Now tangent of pi is again 0. So I will, so if this is my, let's say, okay, this is the so this cannot be pi over 6. Okay, the thing is, if we have to have, this will be half of pi over 6, and then we will have a, so half of pi over 6 will be here. So half of pi over 6 means pi over 3. Oh sorry, pi over 12. So there will be negative pi over 12. Will we have will we have the asymptotes there? Yes. So now this is pi over 6. So if I go that much here, then I will have another asymptote, and again same distance. Here I will have another asymptote. So what will this be? So this is pi over 12. This I can say 2 pi over 12. This will be 3 pi over 12. So this is 2 pi over 12, which means pi over 6. The next will be 3 pi over 12, which means pi over 4. So this will be 5 pi over 12, which can 4 pi over 12, which will be pi over 3. And then next will be 5 pi over 12. Well, you cannot simplify, you will just leave it like that, and so on. Okay, and we can go in the negative direction same way. So this much about is the pi over 6, and the so negative pi over 2. So now you can just repeat the values we got there. Okay, how do you draw? This is how you draw the tangent function. Okay, I'll let you guys try this one on your own. Okay. Okay, now we will move on to section 5.5.